there, this is the 3.1 notes, and in the 3-point notes, our learning targets are graphing quadratic functions and finding and interpreting maximums and minimum values of a quadratic function. So first thing we want to do is graph a quadratic function by using a table, and we know that in our graphing calculator we can type in this function x squared plus 3x minus 1, and we can come up with a nice table of values and plot a nice graph with a smooth curve. It should be a U-shaped graph, and I expect that all of you have exact values. And that's it. That's about it. Plug it in. This one, which graph is the graph of f of x equals 2x squared plus 3x plus 2? So first thing, I can tell that, and we'll learn this later, but as I look at this, I notice that my a value is 2. So we are going to talk about this later. But my a value is 2, which is positive. And positive people are smiling people, so it should be a smiley face graph. So I either have B and C. So A and D are automatically out. So next thing, I just typed it in my calculator, and then I looked at my table, or I looked at my graph, and the only one that'll work is C. There it goes. Okay, next thing. So if you need this, please pause it and write it down. I am going to continue. So we have the standard equation of a parabola. We will be converting later in the chapter, but for right now, it's y equals ax squared plus bx plus c. And your y-intercept will be just your c value. That's where your x is equal to 0. The equation of the axis of symmetry. So the reason why this is highlighted is this is a big deal. X equals negative b over 2a gives you the axis of symmetry. So we talked about how graphs can be symmetric over a line. This is how we can find that line on a parabola. So this is the axis of symmetry. It's also the x coordinate of the vertex. So this is my vertex down here. It's a coordinate point and an x comma y. It's the same as the axis of symmetry. So again, if you need it, stop it and write it down. First one, consider a quadratic function. Find your x or find your y-intercept, the equation of the axis of symmetry, and the x coordinate of the vertex. So it does say begin by rearranging the terms of the function. So the quadratic term is first, then the linear, then the constant term, then identify A, B, and C. So we did that. So here we rearrange. Here's your quadratic, your linear constant, and then A, B, and C. So the next thing we need to do, our C value is your y-intercept. There it is. Next thing is we need to find the equation of the axis of symmetry. This is the equation. We need to plug in our B value and our A value, and we should get 2. So y-intercept is 2. Equation of the axis of symmetry is this guy. Notice that it, oh, wrong color here. Notice that it is an equation. It's not a highlighter. It's not just 2. X equals 2 is a vertical line, so make sure that you have that as an equation. Next one, consider the quadratic function, make a table of values that includes the vertex. So we're using that same problem, okay? But what we want to do is put your vertex in the middle. Yes, you absolutely can use your graphing calculator to come up with this table, but we know we want values on both sides. So we found out that the axis of symmetry was at x equals 2. So then I usually do 2 above and 2 below that x equals value. And then you'll come up with a really nice graph. So they went through, graph these points, boom, 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 and there it is. So new problem says consider the quadratic function, find the y-intercept equation of the axis of symmetry and the x coordinate of the vertex. So first thing, if I put it in the opposite order, I get x squared minus 6x plus 3. So my y-intercept is positive 3. So I know you couldn't see the bottom one, but that eliminates B and D because those y-intercepts are negative. So I am down to A and C, and I need to find the axis of symmetry and the x-coordinate. So I take negative 6 over 2 times 1, and I get positive 3, so that has to be C. All right, so same graph again. So I had an axis of symmetry at x equals 3. So that's here, here, they're all right. Next thing, I need a y-intercept of y equals 3. And the only one that works is this one. There it is. Maximum and minimum value. So we did talk about extrema in chapter 2. So now we are adding it to our quadratics. So the extrema is when you have a maximum or a minimum, obviously. We are going to have a minimum value, and it's going to open upward when A is greater than 0. So that's what I talked about a couple pages ago. I think of it as A is positive, so it's a smiley face because smiling people are positive people. And being a smiley face, it has a low point. If you look at, so here's smiling graph, it has a minimum value. When A is negative, so like this, A is negative, it is a downward facing graph or a frowny face graph. And then we have a maximum point. So this is kind of like those problems where the firework is shot off and it hits a maximum and comes back down. And then you figure out what's the maximum value at, where did it hit the ground, all that fun stuff. So I like these problems because I can do it through, I mean, you can do it in Algebra 1, you can do it in Algebra 2, Geometry, Pre-Calc, and AP Calc, all with a different kind of levels of math, but it's the same, similar kind of problem. You're looking for that maximum, different ways, but, you know, using what we know. All right, so here's our problem. Determine whether it has a max or a min value. Well, A here is negative. So it's a frowny face graph and frowny face graphs. So I kind of do the, is it an upward facing U or downward facing U with my hand? I do it all the time. I'm doing it right now, which is stupid because I'm the only one in this room. But it's a negative, so it's frowny face. So I have a maximum value. So again, for this function, A is -1, B is 2, C is 3. So it opens downward and has a max value. Again, we're considering this. What is the maximum or minimum value? So in order to find that, we need to find the y-coordinate of the vertex. So in order to find the y value, you need to find the x value. We know how to do that. It's negative b over 2a. So I have -2 over 2 times -1, which gives me 1. Now, in order to find the y value, I put 1 back in that equation. So as I put 1 in, there it is substituted, my maximum value is 4. And then it says, consider this function, state the domain and range. You can graph it if you want to, but biggest thing is we are going to have all reals because we can put any value in for x and get a real number value out. But because we have a maximum value, it has to be less than the maximum. So it's going to be less than this. And remember, we are using interval notation. Finally, we have a real world problem. So Souvenir Shop sells about 200 coffee mugs each month. The shop owner estimates for each 50-cent increase in the price, he'll sell about 10 fewer coffee mugs. How much should the owner charge for each mug in order to maximize the monthly income? So what we are doing in words, income equals our number of mugs times our price. That's how much he's going to make. So X is going to be the number of 50-cent increases. I is going to be our income. That's income as a function of X. So income is the number of mugs. So we start with 200 and we're subtracting 10 for every 50-cent increase. Okay. And then, of course, multiplied by price per mug. So it started at $6, and then we are increasing for every 50-cent increase we do. So we have this. Next step, multiply. So this is a FOIL problem. So they did first, outside, inside, last, combine like terms, and then we get this at the very bottom. Okay. Then we rewrote it. So our A term was first. So we have our A, our B, and our C. In order to find our max value, we are, of course, going to do our negative B over 2A. We end up with 4. So that means we are making 4 price increases of 50 cents to maximize your income. So that means that 4 times 50 cents is $2. So the mug price should be $8 total. That's for each individual mug. So how much are we making overall? Well, what we're going to do is we're putting 4 into our formula, and we get a max income of $12.80. So that is it for the 3.1. We will be using this for the entire chapter, so I really hope you took notes or are going back to take notes on this.